All right, so we're getting set up for my new favorite. I'll tell you why. First of all, it ain't because he's wearing that tracksuit, because I do love that tracksuit. That is nice, man. I need that. That's not the reason. The reason why he's my new favorite is because he came from Germany. He came all the way to the United States. He had 1,100,000 cities to pick, but he chose the best one, New Orleans, Louisiana. All right, and the last thing I asked him was, what did he like least about my city? And he said, the potholes. It's bad. It is bad. Our potholes are awful. But his speech will not be. You ready to talk good stuff? I got it right. I'm going to say this right. Thorben Primke.
That's right.
Awesome. I speak German now. But I did it right?
Yes.
Ooh, aha. See, New Orleans can talk good. All right, y'all, bang your hands together.
Hey, everyone. I'm going to talk today about having one code base and targeting 3 platforms, iOS, Android, and web, and how to build a product that will be enjoyed by your users as well as a joy to build. In the end, everything will be in one code base, one NPM install, and slightly different paths for deploying it to the mobile platforms and web. But with a stack that should be very familiar to anyone who has worked with React or web frameworks. My name is Thorben Primke. I work in product engineering at Pinterest. Before we get started, maybe a show of hands. Who here works mostly in front-end web? Got a few. Anybody building native iOS, Android apps using Swift Kotlin? Some people. All right. Great. So this might be very interesting to you as well. And then, how often has it happened that, you worked on a web app, you finished it, and then, I don't know, somebody came around and was like, but we need the mobile apps as well, or vice versa. So, that's a very common scenario, and a lot of product teams are staffed with iOS, Android, web, backend, every single vertical staffed. And so you work in 3 or 4 different code bases. You have the same ticket or the same task to do 3 times, at least for the front end. And over time, this leads to a fragmentation in the product and the code base, to more bugs in the backlog. And so hopefully with this talk today, I can inspire you to try out to build for iOS, Android, and web with one code base. Okay, when I submitted this talk, I was working on a different product this summer where I finally felt like we could use React Native to first build a web app, and then later, once that product was done, also build the mobile apps, but reuse most of the code because the interface, even for the mobile web app, would be very similar to the native apps, except we would have more functionality like maybe live activities or calendar integrations. However, we scrapped that project. That's in the side project graveyard, and we moved on to something else. But so for this talk, I had to find a new product to build. This product here that's displayed is called Empty, and I used it last year when I was still using an iPhone to log my intermittent fasting. As you can see from the UI, it's very simple. It has a single purpose. So when I started fasting again about a month ago, I was looking for similar apps on Android. That's my daily driver. And I couldn't find anything that was just as simple and easy to use as Empty. So I thought, why don't I just clone this product so I can build it for myself to use on Android and maybe even on the web, so that when I start my fast in the evening on my mobile phone, the next morning while I'm working, I'm breaking my fast, I'm on my desktop, I can just go to the web app and finish my fast there. And here is the result. These are screenshots. I'll give a full demo later. On the left side, you see basically what it looks like on iOS, very similar to the Empty product. So try to clone it as close as possible. And then for the web, I try to get a little different interface going because the real estate is just different. It's landscape. You have a lot more room. But we don't really need that much more functionality. So again, I just put the calendar on the right-hand side that shows you the previous days that you had fasted. And then in the center, just how to start one. And then there's also the counter when it runs. You will see this later. So a little bit about my journey in front-end development or front-end mobile development. As you can see, now I've done this a long time. Started with Windows Mobile back in my college days. Then moved on to BlackBerry because we're building enterprise applications. Through that, since that was Java-based, ended up at a consumer startup doing Android. Did that for like 10 years or so, really specialized. And these days, sometimes do a little bit iOS as well, since the majority of the other engineers on my team are all iOS engineers, and we build prototypes of new products. So I help out when I can, especially with AI these days. It makes it a lot easier. But as far as React Native, and when I got introduced to that, and my interest grew over the years. So the first time was late 2016. A friend of mine was working on a React Native app. React Native was just a year out at that point, so it was still very rough. And my experience back then was mostly Android. So he asked me, hey, can you help me fix this keyboard? Keyboards on mobile are always like kind of a hassle. It has gotten a lot better over the years. But that's how I got my start. I helped them fix the onboarding flow where you had to type in an email, password, other information, and really made sure that the content of the screen was always visible with the keyboard present or not. Through that, I took it back to Pinterest, where I think at the time we were building some surveys for users. And the UI was very simple. It was mostly server-driven, but every time you needed a new UI component, like a radio component, we had to rebuild it or build it twice for iOS and Android, deploy the native apps, and that's just adds overhead. I think back then maybe we only deployed every other week to the app stores. We do it much more frequent today. So I found two other engineers in the company that also liked it, someone from growth and someone from infrastructure. And together we figured out how we could integrate it into our native apps at a time when that was not done very often. Through a lot of hard work, we got it done so that most of the engineers would never, or most of the native engineers would never notice that there was a few screens that were driven by React Native. And at the time, if you know Pinterest, it's a very graphic or a heavy app as far as the home feed from a rendering standpoint, the close-up as well. So we targeted flows like content reporting, upgrading a personal account to business account, or the onboarding flow for new users, which was from the growth team, had a lot of web engineers, but not so many native engineers. That was in the app for a few years. Around the start of the pandemic, I joined a team, a bunch of Pinterest people and external volunteers, and we built an app called How We Feel. That was the first time I used it to actually build for all three platforms, iOS, Android, and web. However, back then, it wasn't the same as today. We used Expo as well, one of the frameworks I'll talk about more in a minute. But the web at that point was just a SPA, like a single page application. And it was a big bundle. The more we built to the product, the larger the bundle got. And we got complaints that sometimes just not load because, that whole bundle had to get downloaded first. So it wasn't quite the right experience. Over the following years, we built two more production apps. One of them was just iOS and Android. But again, we got the benefit. Majority of our users were all on iOS, but we used React Native. And the few users that were on Android basically also got the app and weren't told, oh, sorry, you got to wait, or we'll never build it. So that was really a benefit there. The other one we built for iOS first, and then at that time, it wasn't as mature to, again, build for the web. So at some point, we had to scrap the project because we couldn't easily port all the code we had written for iOS to the web in order to unblock a payment solution that we needed. That blocked us from going to the App Store. Fast forward over the last 2 years, I had to go back to native development. We ported an app called Shuffles. It's a collaging product. It was developed, I think, for about a year and a half on iOS only, and then we brought it to Android. I think it took us 9 months, but it was a lot of work, and it's not very thankful work when you're just copying the same screen from one platform to another. We shouldn't really have to do that. The other aspect was these collages have a custom rendering engine because we added like shaders, filters on top. This rendering engine on iOS was built with Metal, the gaming platform that makes it really easy to build those kind of interfaces. When we started on Android, we built an OpenGL, yet another platform. So there was fragmentation between the two rendering engines. We couldn't quite match some of the filters. Next, we were building the viewer for web. And at that point, we were like, okay, we have to find another solution. So we started looking into a cross-platform solution for that. React Native was not feasible for us, but there's WGPU, so like WebGPU, in Rust as a library. So we decided to use that to basically build a cross-platform rendering engine for iOS, Android, and web to ensure that these collages look exactly the same no matter where they're viewed. Very similar to how you would consume a video on one platform or another, and the video does not look slightly different just because of the platform that you're using. So that experience again taught me that when possible, we should try to share as much of the code in order to create less fragmentation between the different platforms. Now let's go to the next part of the talk. React and React Native, they're not that different. So if you used React before, it's still the same. You have components, hooks, props, state management. Your tooling is very similar, NPM, Yarn, TypeScript. Routing, or how you do navigation, has gotten more similar. In the past, it was closer to maybe what we had on iOS or Android. But I think maybe a year or two ago, Expo released something called Expo Router, very similar to Next.js router or 10-stack router, so a file-based routing system. And then the deployments, slightly different between the mobile side and the website, but now the way we deploy a React Native web product is very similar to how you would, for example, deploy a Next.js app. And from a syntax standpoint, you can see like a view just maps to a div. A text element could either be a spam, a p, a paragraph. Image is an image tag. So it's really not that different. So I found it always really great to see when somebody would join one of the projects I would work on with a React background, how fast I could get up to speed and how fast I could be contributing to the product. So what makes RN modern now, or what would I say has changed over the years that I think makes it very different to build with it now versus, let's say, in 2016, 17? Over the years, some frameworks have emerged. Expo was there early, but a lot of us didn't really take it that serious. We used it for a quick prototype, but never considered it for a production app. There's a framework called One. I tried it out before. It's using Vite as the bundler. From a styling standpoint, their library is a little closer to maybe Android, so I liked it. But a friend joined one of my projects, and he's very familiar with Tailwind. So I was like, well, that's a hurdle I would have with other engineers joining a product in the future if they have to learn a whole new way to style things. So let's just adopt NativeWind, which is a Tailwind wrapper for React Native. So Lido is probably the earliest one that made it possible to have both an Expo app and a Next.js app in the same repo. You basically built the same screens, but then mapped them into both of the routers. A new version just was released, I think, yesterday, I saw, so I'll have to check it out and see what has changed there. I think it's definitely better currently if you need server-side rendering versus client-side rendering. And then Rock is another framework that's maybe similar to what my coworkers and I built at Pinterest many years ago, where you try to integrate React Native in existing products, like a brownfield integration. What also changed, I think, is the new architecture. So there used to be an old architecture and a new one. In the old architecture, everything that went between the JavaScript runtime and the native side had to go over a bridge. And that bridge, everything had to be serialized. So that was definitely a bottleneck. Now, so for example, if you needed to change something from a view and needed to get some values back from the native side, it took one render cycle. So I always had to use an effect or wait, so that was cumbersome. Now, any interaction between the JS side and the native side is sync. So we don't have this async problem anymore, and the bridge is gone as well, so it's a lot more performant. And I think we're getting a lot closer to the developer experience that we have on web, or that existed on web, together with the power of the native development and having these apps be really performant. So Expo is one of the frameworks, and it's my favorite. I think they have done a lot for the community, so I'll talk a bit more on that on the next slide as far as like what they offer. But without it, you can still use React Native. It works fine. But you probably manually build your project in Xcode or Android Studio. You handle integrations of third-party libraries. You might have to write some native code too, but you can always also use some existing code from another open source library or from Expo. Managing upgrades, that definitely used to be, I think, the biggest hassle. Sometimes it would be so difficult to upgrade either the Xcode or Android Studio project that we would just bootstrap a whole new project and then copy the code back into it That was easier than actually figuring out what changed in some of the like manifest files, Gradle files. And then if you're not using Expo, you gotta maintain your own build pipeline. So you may be setting up, maybe either using Xcode or Android Studio to build, or you're setting up Fastlane in some kind of like build kite environment in the cloud. So there's extra things for you to manage. Now in the world with Expo, you have a managed workflow, where in theory, you don't even have to build a native app to start your development, and I'll show that in a minute. They provide a client called Expo Go. So as soon as you create a new project, you don't add any other dependencies that aren't in their Expo Go app. You can start the bundler and start running your code and make changes and see them right away. Sometimes, for example, you need to make changes to your manifest to ask for certain permissions, let's say a contact or camera permission. For this, Expo config plugins exist. They ensure that you can basically configure what changes you want in the either Android or Xcode Studio to happen. And every time basically the iOS and Android folder get regenerated, these changes are automatically applied via the config plugins. That was a real nice innovation from their end, because before there was always these snippets that you found on GitHub, you pasted over into your project, and that's when like you did the upgrade and maybe things weren't lining up anymore. Now you just configure with the Expo config plugin, and next time you upgrade, generally everything works. There's a lot of Expo packages, so they expose things like, let's say you want to use haptics in your app to give feedback to the user, or the camera, or access, for example, the file system. There's a lot of packages that they have already built that you no longer have to build, and they're backed by a large company and a larger ecosystem. Expo Router is the file-based routing system built on top of React Navigation and React Native Screens. So it has the same power and performance as React Navigation and React Native Screens, but with the file-based routing structure, which then makes it really easy to see how your app is set up, as well as maps really nicely to web. And then last, there's the ES, the Expo Application Services. Those handle building your apps, submitting your apps to the store, and now also hosting your web app. So how easy is it really to get started from zero to running an app? It's really just running this one, create an Expo app command, and then starting it. So let's go through that. So we can kick off creating one. Always takes a minute for the npm install. That was fast earlier when I tried. All right, almost done. So next thing now, we start the bundler. Oh, maybe we need to switch directories. And now if you want to look at the app, let's say in the iOS simulator, you press the I. Yeah, let me bring it over. You can see loading up, and here we are. And now, let's say we want to change something. We'll go to the index. Not sure why it's complaining, but let's change this to Magnolia Conf demo. We save it, and you can see that change reflect right away. If this was a native mobile product, you would have to rebuild. And let's say we want to see that same app running in the browser. We press the W key in the bundler. Opens the browser. Let me bring that over. And we can see that same app running here as well in the browser. Now, here the layout hasn't really changed. It's just the same layout that they use for the mobile app running in the browser. So it's not ideal, but I'll talk about some solutions in a minute on how to address that. Let's get back to the presentation. Okay, so first, the file-based routing structure. For the app that we just spun up, there's always an apps folder, and then for a construct like the tabs, which is pretty popular for mobile apps, for example, you have the tabs with the parentheses around it. That denotes that we should have a stack with tabs in it. And then inside the tabs, we can see we have an index, the one we just modified, as well as the other screens in the stack, settings and stats. At the root, in this particular case, we also have a separate layout file that makes a normal stack with a modal. So let's say we have something else we want to display above the regular tab layout. That's like lower in the layout. API routes. It's a new addition to Expo Router, I think, as of the beginning of this year. I really like this feature because now I no longer have to go to, let's say, Supabase and create my edge function over there. I can really have my API endpoints next to my app code in the app or in the file-based routing structure. And one use case I use, for example, for the fasting app here is that I save these fast off to a Supabase database, but I didn't want to expose my endpoint or my anonymous key to the front-end JavaScript. So I'm routing everything through API endpoints so that my credentials are protected on the backend, since this is only executed on the server. Another thing that's currently in experimental mode is middleware. I first learned about this when I was working on a web app, how to handle basically the case where you have protected routes and you need to reroute to your login screen. When I was building the other product this summer, middleware did not exist in Expo Router yet. So I had to handle this basically in the front end, in the client-side JavaScript code. This felt a little buggy or not that great because, let's say some particular route loads first. I then check, am I logged in? Do I have a particular state? And then redirect them to the other page. With the middleware part, now for any of the users accessing the web app, we can redirect them basically when the request comes in, a much more native feeling to the web experience. So earlier I talked about the differences maybe between web and mobile, or let's say portrait, also for mobile web, and the desktop experience. And sometimes there's also difference in the components. So for example, for the fasting app, we have a time picker or a range picker, like when you start your fast, or no, when you want to end it, and then also when you started it. In this case, I built one that works really smooth for mobile, has like touch interface and scrolls, but that one wasn't working really that nicely on the web. So I built a separate one and call it like timerange.web.tsx. So automatically the system picks up this component rather than the one that's designed for mobile when it's being rendered on the web. And there I could just use a regular select with options in order to show a regular like selector for the web. Sometimes you don't want to split though at the file level or at the higher level component level, but you want to make some choices within the component itself. The button needs to be slightly adjusted between the three platforms, so you can use a platform selector. Maybe the layout can actually stay the same for both the mobile portrait experience as well as the web experience on landscape, but you want that sidebar, so you can check for the platform constant and then conditionally render the sidebar component. And this doesn't happen really that often, but if you want to check, are you running on Android and a specific API version or SDK version, then you can do something special too. So all the possibilities are there with React Native. So I think something from a mobile engineering standpoint that I generally didn't think that much about in the past was responsive design or layout. I mean, yes, we always build the screens that they are responsive to the screen size, and we had scrolling, so they could be usable. But we generally didn't think about like supporting tablets or going to a landscape format. Most of the apps that I've worked on, we always even force them to be portrait because that just works the best in most cases. So now, if you want to actually use one code base to support these three different platforms, or these two different form factors really, you have to look at, where do I break my design up? At one point, do I go from a portrait layout to a landscape layout? One way to do is just use the Windows dimension, figure out what size you want, and then conditionally render the components. Another way to do it is, for example, rely on Tailwind and their breakpoint system. That's what we use here. Another way to do it is also using Tailwind and directly using the modifier in the class name. Here you can see that if the component, the calendar screen, is rendered on mobile, the calendar and the stats are stacked, but when it's on web or when the size of the screen is more than medium, it's side by side. You can see that by the flex call and then the medium colon flex row. So let's talk about how we deploy. For web, it's pretty straightforward. You run a command to basically package it up, and it puts all the files that you need for deploying your web app into the distribution folder, and then you run an EAS command to deploy it up to Expo. That's all that's needed. For Android and iOS, it's very similar. You run an ESA build command. You can either selectively which platform you want to build, let's say Android because you want to test something, or you just want to build all of them. And then afterwards, you can even use EAS to submit. So no more downloading the binary, going over to the App Store and the Play Store to drop them there, or building some custom script with Fastlane to actually get them deployed and uploaded from your CI. Now let's go into a little demo of the fasting tool. So here it's running on iOS. Let me pull it up in the browser. It's running in the browser nicely. Let me refresh it here as well, make sure it's all good. So let's say we want to actually do a 16-hour fast till 4 a.m. tomorrow. We can start it here. Let's say we started a few hours ago, just so we can see some progress already. Now this is all you see while your fast is going on. The timer goes to the end. Whenever you're ready to break, either when 16 hours are up or earlier, you can break it. Since I earlier mentioned I use the API routes to actually sync the state of these fasts as well as whether one is going on to the backend, we can go over to the web. If we refresh, it should show you the same status. So in theory, you can break it over here. So we can break it, and we can see now the 23rd is highlighted. I don't have anything that actually listens for this yet or sends a push notification, so you just have to refresh the data. Ideally, when you foreground the app or when the user comes back, the screen unlocks. I would just do another fetch to the backend to get that data. But yeah, that's it. And and if you already did a fast on that particular day, it grays it out so you can't start another one till tomorrow. So some considerations. Think about how much of your design applies to both the web product and the mobile products. If there's a large overlap, then there's likely also very large overlap in the code that can be shared. Think about what specific features you may want for the mobile apps, iOS and Android versus the web. Is there a lot of different code needed? Is there native integrations needed? But even if there are, I think you can structure the code in such a way that still the rest can be shared, so you can still achieve a very high percentage of code sharing. And then performance, I would say that's not really an issue, especially the new architecture came out, so your apps can be very performant. But also the native feel or what people think about performance. Yes, you might not achieve it on React Native, but you can also build a really bad app on iOS or Android and have the same not very native experience either. So it really comes down to the polish and craft that each person puts into the product, I would say. And then for me, the biggest benefit is the team structure. You have one team, you work on one code base. People can move between. One person can own one feature across all 3 platforms. There's less context that has to be shared. And so in the end, hopefully that leads to no fragmentation between those 3 platforms, because otherwise somebody builds it for web, somebody builds it for Android, and they miscommunicate, they don't understand something, comes back at QA, needs to be fixed again. So let's recap. So React Native no longer just for iOS and Android, in my opinion. You can also, it's ready to be leveraged for web as well. We have seen how easy it is to start a project and to make changes. You can use it for one platform to get started with. Let's say you're starting a product, you're just building the web app because that product can just live in the web, either on desktop or on mobile, the mobile web. But then later you might want to build a stronger product with integrations on the phones itself. Let's say you want to add a widget, live activities, then it's time to create those apps, and you don't really have to do a lot except add those additional functionalities, make sure it runs well on all platforms. And then last, leverage Expo, their services, and the ecosystem. I think they're a really strong partner to the community. They have done a lot over the years, and their product has really grown from something that I would only use to do a quick prototype to spin up an idea or even reproduce a bug to something I would now use for production. That's it. Thank you.